So I'm so sorry this is going to go over 18 minutes. I've tried. I really tried. I can't do it. I just want to let you know though, the hardest part of this particular part of the exam was finding examples you didn't use in the lectures, and it's good because the examples help so much. Anyways, let's get into it. Let's hurry up. Tinbergen's four questions. Let's start out with Nicholas Tinbergen. He was a famous ornithologist. He won the Nobel Prize, worked with Konrad Lorenz, the whole nine. He came up with the four questions that form the framework for everything else I'm going to talk about in this presentation. I'm sorry, I'm trying to go fast. He broke this into proximate and ultimate questions or causes, right? So proximate causes focus on basically an individual and it's kind of how, like, genetic, immediate, external factors that trigger a behavior in an individual. Great examples: lion cubs lick each other. Mama licks the lion cubs. Lice picking in primates. You don't want lice, I'll pick them out for you and eat them. The ultimate questions are a little different. He came up with ultimate causes that stem on a population level, on an evolutionary level. So this is, what evolutionary advantage, reproductive fitness, successful survival of a species. These are like kind of the what questions, like what happened here. Great examples: mate guarding in elephants. They guard their mates, and that's high survival. Ruby-throated hummingbirds migrate. A lot of birds do. It's pivotal to their survival. We'll get into it. First question is causation. What causes this behavior physiologically? Well, I'll answer that from a Japanese quail's perspective. During their breeding season, the Japanese quail, the males specifically, experience this huge release of testosterone from their hypothalamus up here. Well, right there. Anyways, this triggers a bunch of neural pathways in their mind that essentially results in a physiological display of behavior, right? So primarily, this display of behavior is courtship, like, hey, pretty woman. But this can also be aggression. This is not unique to the Japanese quail. But basically, this study explained the physiological driver behind why Japanese quail exhibit this like courtship display. They basically their brains disrupted and they display that in a unique way. So that's physiological aspect to it. This is a great question. Better questions to be asked. Question number two. This is a good one. Development. How does this behavior develop? This is still a proximate cause because they're in this realm. He's kind of talking about development throughout the lifetime of the animal, not necessarily development over time. So like my example is play in juvenile rats. The ontogeny of play behavior is basically juveniles do it and adults don't, and adults only exhibit play behavior towards juveniles. And the reason behind this, I know we're kind of talking physiology about the last question, but there is a reason behind this. The prefrontal cortex has to develop, and the prefrontal cortex is responsible for impulse control, socialization, fine motor skills, and play behavior is essentially a demonstration of the development of the prefrontal cortex. That it's definitely case by case basis. So baby rats that don't experience great maternal care, that have a genetic defect, that are sick, that are stressed environmentally, they don't always exhibit play behavior, and so it doesn't always develop. But the development is actually backwards from a lot of traditional development. It occurs in early life, and then it declines super sharply as they reach adulthood, mating stage. And essentially, the only time the adults ever do it is towards the juveniles. But yeah, this is genetically, you kind of have to be predisposed to be a little more social, and some rats are, some rats aren't, and they, address nuances here and there. But in a general sense, it develops and goes away, which is cool. And we'll address why later. Ultimate causes. We'll start with these. Again, this is on a population. This is kind of a what. What advantage does this behavior give to fitness overall? So my example is meerkats. We all know meerkats alarm call. Well, the reason they do is because alarm calling from the sender is pivotal to the sender's survival because it's pivotal to group survival. And a single meerkat is not a very successful meerkat because meerkats have what they call mobs. Like when there's a group of them, it's mob. It's kind of cute. They rear their young, they hunt, they travel, they live as a pack. And so essentially the evolutionary advantage to being able to let your buddies know, hey, you're about to get ate up, you might want to go hide, is that you survive because they survive. So this definitely it's definitely evolved. It develops in individuals, but it's more of an evolutionary sense. The entire population does this. And they detect the predators obviously through senses. They smell them, they see them, and they let each other know, which is pretty useful, I think. Last ultimate cause is evolution. Tinbergen is not the first person, not even close, to ask this question, but it's a good one. How does this behavior evolve over time with this population? My example is food caching in red foxes. So vulpes, red foxes, they had a super competitive edge when it comes to food storage in relation to pretty much anybody else around them because they developed the ability, their population developed the ability over time to cache their food. This is driven by a bunch of stuff. So number one, it allows for one single energy expenditure in one singular hunting trip to result in a surplus of food. So you go out hunting one time, you get 5 rabbits, you eat 3, you take 2 back, you have some for later. So you only have to hunt one every 2 to 3 days. So number one, you're healthier because you're not spending as much energy. Number two, you're not risking predation as much because you're not going out as much. So that's a huge driver as to why this behavior developed as well. Number three, which is a big one, is food scarcity. So in times of food scarcity, what vulpes eventually figured out is that when they really get on them and they really just slaughter them out in one big go, if they take that back and they save it, um, they can survive longer than other species or other individuals of their same species that don't develop this behavior. So essentially, there's a lot of reasons why individuals that develop this behavior came out on top, but eventually their entire species learned to do it, and now they do. And that's evolution for you. Thank you, Darwin. So next is let's back up and talk about proximate causes. A lot of proximate, and I'm not saying ultimate causes are not driven by hormones because that's not true, but proximate causes are primarily driven by hormones. And this happens in two distinct ways. So organizational versus activational effects. Let's explain. Hormones can affect physiologically, neurologically, long-term permanent effects on the body. So these are irreversible. These are critical in, the rest of your life. They form the cornerstone for other possibly activational behaviors that you're going to exhibit throughout your life. These behaviors develop and don't go away, and it's because these hormones either existed and made you that way or exist constantly. They were called organizational because they organizationally form your behaviors and who, as an individual you come out to be. I say you, and I mean the individual frog or whatever we're talking about, right? In contrast, the activational effects, these are short-term hormones that fluctuate. They can fluctuate on a lot of reasons: seasonality, life stage, or sickness, environmental factors that have nothing to do with what's going on internally. Are you taking in a bunch of pollutants? Who knows? Stressors are other stressors. So breeding, even, I think of breeding when I think activational effects because it ebbs and flows. It comes in waves. It's not permanent necessarily, but it happens, So I can explain this better over examples. So let's get into examples. These are my two favorite slides in my presentation, by the way. So I hope these are good. Organizational effect is on the northern fur seal. So this was really cool. The organizational effect is not the mother, you would think. So no, high density colonies naturally produce more temperamentally aggressive babies. And let me explain why. So, and it's based on hormones, right? This is attributed because the mother herself, while carrying her cubs, is experiencing stressors. So that's competitiveness for food. That's other resources, competitive space. That is breeding pressure. So she, in her hormones, are under higher. Sorry, that was my laundry going off there. She's exhibiting higher levels of testosterone and cortisol, and that is being passed biologically through her to her babies. So when these pups are born, the idea is that the pups are born to the mother. And if the mother is in a stressful situation, the pups will be born into a stressful situation. That's the reason these hormones develop the way they do. But these hormones affect these babies for life. So if you have a mother that is under stress and you have babies, her baby seals are going to be temperamentally more aggressive for the rest of their life to offset the fact that they were born into a more stressful environment. This is an organizational effect. I thought it was super cool. Let's move to activational. This is my favorite slide. Sexual cannibalism in the Australian redback spider. Let's talk about it. So Australian redback spiders, to begin with, they have a lot of sexual dimorphism. The males are this big, they're teeny bitty. The females are not, right? So they both exhibit this hormone called ectosteroids when it's breeding time. Background information: 80% of male Australian redback spiders will not breed in their lifetime. They're this big, they're going to get stepped on. But the 20% that do breed, it's like fireworks when they see a woman. And so they decide that they don't decide, their body decides, I'm going to release this huge amount of ectosteroids because I really, really, really want to breed, because this is my chance. Because also, after breeding, if the female doesn't eat them, they are sterile. So this is their one and done. This is it. They physiologically, going back to Timbergen, right? Physiologically, they figured out that if they offer themselves as a food source to their, female counterpart, that they are super successful in breeding, right? But if they don't, they have less success and they might get eaten anyways or just kicked off the nest. Females, let's talk females. Ectosteroids make females super aggressive. Therefore, A, she's willing to eat her mate. She's mad at him for whatever reason. But B, if you don't offer yourself as food to me, I hate you. And that's how the hormones affect her. Now, this is activational because it goes away. It's activational for the male because it only happens one time. It's one and done. But for the female, it's activational because once she breeds and once she has her eggs and her babies, these ectosteroids go down. She stops releasing these into her body and she goes back to her normal self, which is not very aggressive. And I'm looking forward to the research that studies whether or not she regrets eating her mate afterwards. So this was my favorite part. I hope this was a good example and I hope you enjoyed it. Let's move on. If I wanted to test, why does she eat that man after they breed? This would be the way to do it. You have, essentially, there's a lot of ways to test a behavioral process. But two we're going to focus on: cross-sectional and longitudinal studies. Basically, cross-sectional studies are a snapshot in time. These studies are great if you want to observe behaviors and patterns and compare them across a large scale. If you want to compare them across different groups, it's different than a longitudinal study because, like the name implies, longitudinal is over a long period of time. This is not the case with cross-sectional studies. These are short and sweet. Some characteristics of them: short-term data collection. They are typically low casualty because if you're observing a large group, you're a distant observer a lot of the time. So not too high stress. You can compare multiple individuals or multiple populations or multiple variables super easily with a cross-sectional study. That's what these are for. So it would be great if you're studying 300 individuals at one time, you're probably doing a cross-sectional study, right? In contrast to a longitudinal study, like I said, long-term, longitudinal studies are based on repeated observations of the same individuals or variables over extended periods of time. So longitudinal studies, that they allow you to really hone in on what the exact thing you're trying to watch. So these are great if you're trying to, let's think back to our rats, okay? If you're trying to test, how does play behavior develop in rats? You're going to watch the rat over the course of their lifetime, right? That's a longitudinal study. And you're probably going to do it with a few individuals, smaller group, and you're going to observe them frequently and multiple times, right? So not a snapshot. This is progression over time. Again, long-term, the characteristics I'm listing here: long-term data collection, you get nuance with these. You can account for individuality. You get detailed observations. We're going to get into the comparisons on the next slide, so let's just move on. Comparisons. Let's hit the shared pros between these two studies, right? So real world relevance. They're both super relevant to the real world. They both offer great things. It just depends ultimately on your study and what you're wanting to do. Number two is comparative analysis. You can absolutely have comparative analysis with both of these studies. It again is depending on the study, but specifically pros for longitudinal studies: detail and nuance. Like I said, you can account for outliers. You get super detailed, up close, right in your face information. You get to watch changes over time, and but this does come with some cost, literal cost, as in moolah. It's cost intensive because it's time intensive. You have to pay people. You have to use sometimes specialized equipment. Not to say cross-sectional studies don't, but just saying. So it's a little more in depth, I would say, maybe than a cross-sectional study, and they can be high casualty because if you're doing a terminal study, that's a lot more high casualty than just, I'm sorry, that was my 18-minute timer. I'm not getting through this in less than 18 minutes, so I'm just going to have to not make a 100 of the start. These can be high casualty. In contrast, cross-sectional studies, quick data collection, large-scale observations, and they're can be more cost effective and less time consuming ultimately. And if you're a distant observer, obviously it's lower casualty. The cons: you lack detail. You don't account for outliers all the time. You don't account for nuance, and you can have high bias because if you're one person watching 300 birds, shoot, you better be wearing some bifocals is all I got to say. So examples of this, I chose for my cross-sectional study, I chose the behavioral analysis of short and long-term kennel domestic dogs. So the objective of this study was to compare the overall well-being, what they define as well-being, of short-term and long-term kennel dogs. They did this through a variety of ways. They interviewed handlers, they collected urinary samples and did urinary hormone analysis for cortisol levels, all this stuff. They did a great job, really, with this study. But what they ended up finding was that it was really not the length of the stay in the kennel, it was the quality of the kennel experience. So really, it wasn't much on the hypothesis side. But this was a great example of a cross-sectional study because they did this at one point. It was one snapshot. A urinary analysis happens at that point when they're peeing, and that's all. So that's your cross-sectional case study, and they did it across different groups in different areas. A longitudinal case study. We've got dolphins. This study was done off the coast of Italy, and it was based around like 4 different gas pipeline structures, essentially. And they wanted to observe and compare like bottlenose dolphin behavior in relation to those 4 pipelines. This study went on for 3 years. I would consider it longitudinal if you ask me. Basically, they wanted to determine whether or not dolphins would avoid structures like this, whether or not they were, acting differently. Again, ultimately didn't really matter. Dolphins are almost as smart as us. They figured out as long as I'm, being cautious, I'm fine. I can hunt there and things. So that was longitudinal versus cross-sectional. I hope that was okay. I'm really trying to hurry. The last part of this, oh no, my gosh, it's not the last part of this. Gosh, I'm so sorry. Signaling. So let's get into it. Cooperative signaling. Cooperative signaling is communication where the sender and the receiver experience gained benefit together. So mutualistic. This is symbiotic relationships. This is, tit for tat. The sender benefits are cooperation and increased group survival. And obviously receiver benefits are increased safety and group survival. But costs, the sender could draw attention from predators, and the receiver could develop some overdependence and rely on this. So that's cooperative signaling in a nutshell. My example of this is cleaner fish. So remoras, there's a bunch of names for them. Essentially, they're little sucker fish that attach themselves to sharks. And what they do is they signal to the shark, I'm not prey, I'm not prey. And the shark is like, what do you offer me? Essentially, they eat the parasites off the shark. So they attach themselves, they eat the parasites, they eat the shark's leftovers, and in return, the shark gains no parasites and improved health. So that is cooperative signaling. Dishonest signaling. Dishonest signaling is lying. How else can you say it, right? So it misrepresents a situation for self gain. This is through mimicry, false alarms, fake outs, whatever you need to. If you're thinking of being deceitful, that's dishonest signaling. This communication 99% of the time only benefits the sender, and it only benefits the sender some of the time because the sender can receive like increased access to resources, safety from predation, or like intent to flee a risky situation, right? But these benefits do come with a cost of losing cooperation with their other species or other individuals of their species, and also, they could still reveal themselves to predators doing this. So it's successful sometimes. The only way a receiver can benefit from this is if they hear a fake out predator call and go hide. There's not much on the receiving end, unfortunately. That's just the name of the game. But the cost is decreased resources, increased predation, any just tit for tat, exact opposite what you're thinking for the sender. So my example is male bowerbirds they make these huge nests. They make them up fancy to make the females feel like they have a better mate. In reality, the nests have nothing to do with how good of a mate they are and how fit physically for reproduction they are. It's just look at me, I have a fancy house. That's dishonest signaling. Incidental or cue signaling is when an individual is picking up on a signal that's not intended for them. So bats do this. They smell the predators, and the predators aren't releasing pheromones on purpose, but the bats are picking up on it and they realize they don't want to get ate. So they stay inside. They stay in their cave. You know what I'm saying? This comes in many forms. It can cause environmental change movement, the way something's moving, literally any unintentional factor that an individual is picking up on that was not directly signaled to them. That's cue signaling. Our last form of signaling is spiteful signaling. This is really interesting. Humans do this, and it's interesting for sure. But spiteful signaling is when an individual communicates information that's harmful to itself and others. This is a lot of this is associated with like aggressive behaviors, being territorial, breeding. Occasionally, benefits for the sender can be they're warding off their competition. But this still comes at a large cost as they can incur like physical harm if they're picking a fight. Also, the receiver could incur physical harm if they decide they want to play tough, right? But this can ultimately result in increased social awareness. So as like I think lion and lion cubs, right? If the lion cub's being a little too much, the lion's going to let them know, and they get that. And that's a diluted sense. But ants do this. They exhibit super aggressive behavior. They don't care. They will die for their chance to get to that queen, right? They do this a lot towards lower ranking ants to prevent them to being able to breed. It doesn't always work, and that's I guess how you get to be a higher ranking ant. I don't know. Don't ask me. I'm not an ant. So that spiteful signaling. Seriously, the last part of this is the Jagielski study. I'm sorry, I don't know how to pronounce his name, but Jagielski and crew. This was a super interesting study. You were right. You were right. Once again, you normally are. But polar bear eating habits have shifted. Obviously, climate change is thawing everything out rapidly. So not only are ice intervals getting shorter, but there's less ice to begin with, which is really, really putting a damper on the polar bear's ability to hunt for their primary food source, which is ringed seals. So this study, they focus in on the common eater, which is a waterfowl, a type of duck, basically. They nest during winter or during summering seasons. So essentially, bears are shifting from more hunting to almost like foraging behavior according to this study at least. And the purpose of the study was they wanted to see how this foraging behavior exists and what the dynamics are between the two species. They're both Arctic species. They in a focused in sense, the purpose of the study was to test the hypothesis that foraging for eater eggs could prove highly beneficial in early nesting season, but benefits decrease sharply as eater eggs are being ate up by polar bears. In a huge general sense, the authors wanted to use a cost-benefit analysis, essentially, between the two Arctic species to further the knowledge of habitats, interactions, and the decision-making process of these individuals. Because not only does it affect the polar bears, it affects maybe the decision-making process of where am I building my nest as an eater, right? So let's get into the specifics, right? The species and study site description. So mentioned in this study are a lot of species. So this study does a lot of compare and contrast, which is good. They compare to a lot of publications that they cite. So a lot of them, lesser snow geese, like big-billed murres. But the primary species are polar bears and common eaters, which is polar bear right there, common eater right there. And then they do mention the ringed seals quite a bit because that's the primary food source for the polar bear. But again, they cite all these sources in their site listed. The study site strategically chosen because of two reasons. One, on the polar bear side of the house, they have a known subspecies existing colony of polar bears called the Fox Basin subpopulation, and they know these bears come here this time. It's reliable. Number two, this study site, the Middelvic Island, which is basically there's a large island called Southampton Island, and then in a kind of sea curve area of sea within the Southampton Island, there's Middelvic Island, and this island is the hotspot. It is the largest nesting colony of eaters that we know of. So obviously, if you've got a I feel like the reason they chose this site is obvious. I feel like it should be. The interaction between this particular population of polar bears was targeted because there was a lot of eater eggs that's going to result in a lot of, a lot of data being collected. So, let's get into more details. Methodology. They chose obviously to do this. The June and July. This is a wintering or this is a summering event, right? They don't do this during the winter because eaters don't nest during the winter. So they use drones to track foraging polar bears for 10 days. They chose kind of the middle of the nesting season, just based on the median arrival and median lay dates of the eaters, which they cited another study for that. But they could differentiate between individual bears to a certain degree. Their differentiation kind of varied, and they did say in there that if they were unable to differentiate, like based on markings or behavioral patterns or what have you of an individual, that they just counted it as an extra. So they did say like take that with a grain of salt. And it goes the same for sexes as well. So they assigned two different weight classes to kind of differentiate between the male and female habits. Again, they weren't able to sex the exact individuals, but that's the name of the game when you're using drones. You can't fly a drone in a polar bear face. It's not gonna happen. They also on the behavioral side of the house, they differentiated between empty nest visits and foraging activity. So they were able to see if they were actually chomping and chewing on stuff or whether they were just sniffing around. This was a good study. I feel like they covered their bases and they cited a lot of other good work in the study. The math. I thought this was going to be convoluted. It's really not. So the math is based on a lot of, again, preliminary work. This is not a new concept, and this has been done with a lot of other bird species. But the specifics go as so. They estimated that an eater egg, one singular eater egg, contains 1,090 kilojoules per egg. Now they also found they used the average clutch size, which is 2.85, so almost 3 eggs per clutch, and got the number 2,803 kilojoules per clutch. So that's like the gross average of what a polar bear is going to get when they ready to nest, right? So the formula they came up with is it's a step further, right? So the volume of oxygen, this number that they're plugging into this formula is based on 1 liter of oxygen, and it's the energy cost that the 1 liter of oxygen is taking up. This also in this formula, they account for the polar bear's ability to digest fats and proteins, which is like the main portion of what an eater egg is consisting of. Not specific to eaters, that's all eggs, but there's a lot of like metabolic rate calculations in there. And then the last part of this calculation is the speed that the bear is walking. So how fast are you moving? Obviously, a run, a sprint, or a walk. Estimated oxygen cost that they came up with was 19.66, almost 20 kilojoules per liter. And then the average speed was 3.4 kilometers per hour. So that was 16.67, again, almost 17 kilojoules per kilometer per hour. It's easy to follow the math, the statistical analysis. I'm glad you said don't mention that because it was over my head for sure. But the findings and conclusions they came up with in the early season, they proved their hypothesis correct. In the early season, the bears consumed over 20 clutches, and in 10 out of 24 foraging bouts. Foraging bouts is what they call the foraging, behavior. During the mid-range of observation, the bears consumed 10 clutches in 15 out of the 24 foraging bouts. And as the season progressed and the eater eggs, they declined because they're all getting ate up. The last 3 days of observation were hard. They were bad for the polar bears. They no more than 8 clutches were consumed in any singular foraging event, and out of all of those, 3 foraging bouts were unsuccessful as a whole. And they did find that bear energy costs remain constant over the course of these foraging bouts, whether they're successful or not. I mean, the energy exertion is still the same. But this study was not able to attribute like swimming behaviors, which is common in polar bears. Late season foraging attempts, because again, they did this in the mid range. Both of these behaviors would incur a lot more energetic cost up front and then for a lot less benefit. So they did kind of prove their original thought that this is super successful. This is super good stuff in the early season. The findings, like I said, early season is when this is going to be really beneficial to polar bears. They did not do a follow-up study, but they're in their future directions. Essentially, they mentioned it might be worthwhile studying the later season eater nest foraging bouts. That is it, I do believe, for my presentation. I'm so sorry this went over time, but I hope everything was good other than that. So thank you. I really love your class so far. It's a really good class. It's teaching me a lot. It's teaching me a lot more about physiology than I thought I needed to learn, but it's a really good class, and I hope you got something out of this. Thank you.